Okay, let's continue. Question number 14. First, the 13 questions I recorded in the previous video for chapter 3.5. This is second part practically, the rest of 7 questions, so total will be 20 questions. All right. Assume that when adults with smartphones are randomly selected, 49% use, here it is, 049, use them in meetings or classes. If 8 adults adult smartphone users are randomly selected, find the probability that exactly 4 of them use smartphones in meeting or classes. Okay, so since the formula is P of x is equal n factorial over n minus x factorial, blah, 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 we need their y, right, to calculate y. Therefore, q. Therefore, q is equal 1 minus probability of success, which is equal 0.51. To use precisely, find probability precisely for x is equal 4, I plugged the data here, factorial 8 minus 4 factorial, 4, and so on. All factorials, all data we need. But you can also use online calculator for binomial distribution. I will place under this one also, and you just can plug this data in there and we'll give you result, which is going to be 0.730. For the next question, number 15, is given n is equal 124, probability of success equals 0.38. We need to find mean, variance, standard deviation. Mean for binomial distribution is equal n times p. So which is going to be equal 124 right here times probability of success 0.38 equal 47.1. Next, variance is equal npq, which means I'm taking np product 47.1 and multiply by q, which means 47.1 we multiply by 0.62, and that is equal 29.2. And standard deviation is equal square root of sigma squared, which is equal square root of 29.2, which is 5.4. Fix this 5. Okay, question number 16. 38% of questioned women find themselves as fans of professional baseball. We need to select 6 women and ask each one of them if she is a fan of professional baseball. So it's given 6 total women with a probability of success 38% or 0.38. And accordingly, Q probability of failure 1 minus 0.38 equals 0.62 or 62%. To find, let me clean this. So mu is equal n times p, which is going to be 6 times 0.38, right? And it will be 2.3, and then sigma squared, that's a b. Sigma squared, it's going to be equal npq. N times p we know is 2.3. And we multiply on the top of that 0.62, right? Because it's a q, we need to multiply. And we are getting 1.4. And lastly, we take square root of sigma. and we get sigma square root of sigma squared, and we get square root of 1.4, which is 1.2. And what conclusion we can draw? That in out of 6 people in average, 2.3, which means in average 2.3, which means between 2 or 3 women with plus minus 1.2 standard deviation, they say that they are excuse me, fan of professional baseball. Question number 17. Okay. About 76% of workers, let me, it doesn't look good. Well, let's leave it like that. Okay. 76% of workers know what their CEO looks like. You randomly select, here is 76%, 0.76. You randomly select 6 workers, here it is, and ask each if they know what their CEO looks like. Complete parts A through D. Okay, A, we need to find mu average, which is equal N times P, 0.76 times 6, which will be 4.6. Sigma squared, which is our variance, is equal NPQ, which is equal N is 6, P is 0.76 times, Q is 0.24, here it is, which is equal 1.1, or you can take 4.6 instead of these two, just 4.6 multiplied by 0.24. And standard deviation is at the square root of sigma squared, which is going to give you 1.0. So the conclusion we can draw out of 6 workers, approximately 4.6 employees, which is going to be 4 or 5, they indeed know their how their CEO, what their CEOs looks like. In this average 4 and 5 plus minus 1 standard deviation. Question number 18. Something similar to the previous one. 59% of men in this case consider themselves professional baseball fans. You randomly select 10 people, here we have 10 people, and ask each if they consider themselves a professional baseball fan. Find the probability that the number who consider themselves baseball fans is exactly 5. Okay, we are going to find exactly 5, at least 6, and less than 4. So the probability for binomial distribution is P of x equal n factorial, which is this formula, obviously. Okay, so we have all data here. We have n, we have x is here 5. So once we can use the online calculator, it will be under the video, obviously. You can plug data and you should get 0.209. For probability of x is greater equal 6, you either, if you are calculating by hand, then since greater equals 6, so you have to calculate for 6, for 7, 8, 9, maximum is 10, and add them up. But if you are plugging numbers in the calculator online, then there is a window for greater than, less than. You will choose which one it is. You have to choose greater equals 6. Enter this x and n and probability of success, and you will get your result. Accordingly, probability for x is less than 4. You will find the window where it suggests the less than case, plug there 4 and other data that is asking for, and you will get 0.06. Or manually, if you're going to count it, it's going to be probability of 0 plus probability of 1 plus probability of 2 and 3, and add them up. Question number 19. So we have 33% all adults, probability is equal 0.33, which means Q is going to be equal 1 minus 0.33. This is ridiculous. I wish they would never update this program. I guess they will fix it. So P is equal 0.33, hence Q will be equal 1 minus 0.33, and that it's going to be equal 0.67. Okay, so this is probability of success for who likes cashew. Oops. Often adults says cashew are their favorite kind of nut. You randomly select 12 adults, which means n is equal 12, and ask each to name their favorite nut. Find the probability that number who say cashew are their favorite nut is exactly 3, at least 3, and at most 2. Okay, so you just plug in the formula. X is equal 3, n is 12, probability success 0.33, and you will get this result. And then you will choose the window greater equal 4 or less equal 2, plug the numbers and get the result. I have here results I got, so if you want to check yourself, if you are working properly with the formula, you can plug my data and see if you get the answer correctly. And the last question, again the same way, assume that the random guess, these are made for 8 multiple choice questions on the test. 8 multiple choice questions on the test, so that n is 8 trials, each probability of success is 0.2. Since you have 0.2, you can use a table of binomial distribution, which is given right in the problem of question number 20. To learn how to work with that table, you want to open video lecture 4.2 continuation. There are 2 video lectures 4.2. One is I think part 1, the other one is continuation part 2. You can use the table if you want to, or you can plug again in the formula for binomial distribution. When you plug, you are going to find the probability of no correct answer, which means no correct answer is going to be x is equal 0, which is going to be equal n is equal 8 factorial, 8 minus 0, and times 0 factorial, times probability to power x is 0, and q 0.8 to power x, n minus x. N is 8 minus x is going to be power 8. Okay, so the result is going to be probability of x is equal 0. Yeah, it's going to be 8 factorial. Here going to be 8 factorial. And here will be 1, because probability factorial of 0 is equal 1. And then probability to power 0, so 0.2, I can place instead of probability 0.2, which it's not going to change much because it's going to be 1 anyway. And then probability in 0.8 to power 8. And once you plug all this information, let me see, I'll open the probability. So probability of success, it's gonna be 0, I'm plugging. Then it's asking number of trials, I'm plugging 8. Number, okay, probability is success 0.2, I'm sorry, 0.2. And probability, number of successful trials, it's gonna be 0, right? That's our x. Okay. So if and then I click calculate, this is gonna be equal 0.168. Don't follow my numbers because I don't know your problem, how many decimal notations it wanna round up. Just read it. If it's 2 decimals, then you round till 2. If it's 3 decimals, then you round till 3. It's entirely up to you. Okay? All right, thank you for watching, and I'll see you next time.